Hello, my name is Xunhu. Welcome to my web search engine demonstration for coursework 2. This project is a fully functional CLI search engine built in Python, targeting quotes.toscript.com. It features an inverted index, TF-IDF ranking, and spelling suggestions. First, I'll run the build command. The crawler strictly respects the required 6-second politeness window between requests. Once finished, it serializes the inverted index and TF-IDF metadata into a local JSON file. We can quickly load the saved index. Let's print a word like indifference. The system successfully retrieves its frequency and exact positions in all one time. Next, the find command. I'll input a query with mixed cases and punctuation. The system normalizes it and uses highly optimized set intersections and logic to find pages containing all words. As an advanced feature, the search results are not random. They are mathematically ranked using a custom TF-IDF algorithm, scoring relevance based on term frequency and document frequency. For user experience, I implemented an intelligent query suggestion feature using Gestalt pattern matching. It catches typos and suggests the correct phrase. At the macro level, main.py serves as the central brain. It implements a robust read-eval print loop interface. For instance, it actively prevents system crashes if a user tries to search before loading the index, and gracefully handles unexpected interrupts like CTRL+C. Next, for data acquisition, we have the crawler module, my primary design decision here was ethical web scraping and network robustness. I strictly enforced the required 6-second politeness delay to respect server load and wrapped the HTTP requests in robust exception handlers to prevent network timeouts from terminating the system. Diving into the data layer, the indexer module relies on a nested Python dictionary to build the inverted index. This data structure maps words to URLs, frequencies, and exact positions, guaranteeing all one-time complexity for word lookups, which is highly memory efficient. Finally, in the searcher module, I prioritized both performance and user experience. For multi-word queries, I utilized Python's native C-optimized set.intersection with a fail-fast mechanism to speed up filtering. Furthermore, I integrated the TF-IDF mathematical model for precise result ranking and used sequence matching algorithms to flip to provide those intelligent spelling suggestions we saw earlier. To ensure system reliability, I built a comprehensive automated test suite using PyTest. By heavily utilizing Python's native unit test.mark, I achieve deterministic testing across all components without any actual side effects. Specifically, for the CLI module, the key highlight was patching sys.exit to safely test the infinite REPL loop without crashing the test runner. For the crawler, I mapped HTTP responses to simulate network timeouts, verifying the system's robustness without spamming the live server. For the indexer, I mapped file I/O operations to rigorously test the JSON serialization process without touching the physical disk. And for the searcher, I injected a pre-populated dummy index to strictly isolate and validate the complex TF-IDF calculations and spelling suggestion algorithms. As you can see in the final report, this systematic approach resulted in a solid 85% overall coverage. The core modules reached nearly 90% with uncovered lines strictly limited to extreme edge case exceptions, proving the engine is highly robust and production-ready. Here is my Git commit history, demonstrating an incremental and systematic development lifecycle rather than a single bulk upload. Finally, my critical evaluation of using Gemini. First, it was a fantastic pair programmer, significantly accelerating my logic design for the TF-IDF and spelling algorithms. However, it failed during testing. It generated a faulty mark for sys.exit that caused an infinite REPL loop. I had to manually step in, debug, and intercept the system exit signal to fix it. Second, this mark trap was actually a profound learning moment. It taught me that while AI is an incredible accelerator for boilerplate code, it lacks the deep architectural context of a full system. Finally, blindly copying AI code introduces severe risks to system reliability and academic integrity. As developers, we must maintain strict accountability. My conclusion is that AI's role in modern software development is a powerful co-pilot. The human oversight and rigorous automated testing must always remain the pilot.